You're not really talking about real-time responses in this, are you?
No.
I
No.
mean, you know,
No.
if I did a search,
The
it
response.
might take 5 minutes to cut down to the relevant sources, but I get everything I get is relevant and sound. It's sound by definition. That's it. That's all I need.
Okay, so let's say, but isn't that sort of going back to the search engine paradigm again? So let's say I have a question about Dodge Ram, and I query them, and I get 5 relevant sources, but I still don't have the answer to the query. If I process them manually, then yes, maybe it could be something
No,
like...
I was just referring to the time that's taken to do this.
Or to select the sources?
Yeah.
That's fast.
The time, I mean, your own, I mean, you're talking about the time penalty explodes here.
If you do the source selection, all this is gone, right?
Mm-hmm.
So yes, that would be fast.
But I mean, the overall
Response time is...
response time, I mean, my question was, if I can be guaranteed that I am looking at relevant sources, and yes, I get sound answers, it does not really concern me very much if it takes a little longer to do that, provided that everything is correct.
Yes. That's an argument for semantic web. Sometimes we say, like, if you want, there was one query that I wanted to get is give me, and I didn't have time to give me all the schools and universities that have a computer science department. They are hiring within 50-mile radius of Washington, D.C. It was a very important query for me a couple of months ago.
Yeah.
I would spend, if they say, okay, even in this case, it's 5 hours. I would wait for that if it's guaranteed sound and complete. Yes, good observation.
So back on this, the same as statement, that means that you could potentially have as many same as statements will actually raise to the power of the number of pieces of data you have.
Yes.
So that just seems like a completely untractable way of solving that problem, to use that same as statement. And so, yeah, is there...
So you don't load all the same answers. That's I think is the key. Now again, we are using this rel same as. So, for example, DBpedia or GeoNames or something like that, you have these millions and billions of, well, not billions, but millions of same as's. But you only load the same as's that are relevant to your query.
Yeah.
But if you can define it.
Yeah, I guess, because the point is, it just seems like that the whole concept of the same as is broken. That's fundamentally the problem, and not that your algorithm can't handle it well, but it seems like there's got to be a better way to do that.
Can we discuss it offline?
Yeah. No, it's not. It's just a comment. It's not a question.
Maybe we'll come back to that.
Yeah, because that's an interesting.
In general, in logic, that's what happens, and every complete, and there is no, I don't want to say there is no better way, but it seems to be like always an open problem.
Yeah, if you want a precise answer.
Right, so
you always
everything you
end
have,
up butting your head against that
right,
same
it's also in different contexts, in planning, everywhere, when you add this equal, it will automatically, you see this kind of time, so even if you could pre-process it, done, it will still be not helpful, or if you have too many data sources, it will just take years.
Yeah, you have to basically be willing to live with approximate answers, because, to get precise answers, I don't think there is any other way around it.
Just one point for clarification on this chart up here. Have you done anything to determine if it's the number of same as statements or some other property that's really the contributing factor behind?
I'm glad you're here. Yes. It's a very, very leading question. When we got stuck and I was in a panic, and basically what we did a test. What happens is when you have a very dense same as class. So if an URI A matched with a lot of those, So that's when things slow down. If you have A to B, B to C, C to D, that's fine. And a lot of, like the real world experiment when we did with the Hawkeye data was very fast because it's a monolithic same as statement. But if you have this kind of situation, which you could, but I don't know in real world you would, there is actually a website called sameas.org, which is open link data. They're connecting that, and I put in URLs there, and I get about 8 to 9 equivalence classes. That can be handled, but yeah.
If you have something like synonyms or something like that, so that's when you get that kind of thing.
Yeah, I mean, you could just explode,
right.
Or, you know, if the power law, I mean, you know, isn't that what it's called, the bigs, collect bigs? So, yeah. So it depends on that. Maybe, you know, maybe semantic web would be all only, you know, 20 big data sources. That's the 20 big guys. And then you are not going to have that much of the density. But yes, that's a very good point. It's not the number of sources. We have done millions, and they were fine. It's just these guys. And these guys, even when it goes to like 25 or 50, it just jumps all of a sudden. So I think it is the real reasoning for sure. Okay, conclusion. So we formally defined a metadata scheme to summarize the content of the semantic web. So fire away. CJ? Follow.
Nobody?
I have a question about the real statements. There's three arguments: the documents, the annotated term, and the goal term, the query term, right?